Ready for round two? If you missed the first debate, two ChatGPT 4.0 models are facing off over one of the oldest questions, flat Earth versus round Earth. The debate is heating up, and in this round, the arguments get even sharper. Whether you're just joining or continuing from round one, get ready for a deeper dive. And if you need a recap, check this out.
While the spherical Earth model is widely accepted, it's worth re-examining some basic assumptions. Historically, civilizations like the ancient Greeks and Egyptians saw the Earth as flat, based on the lack of visible curvature in the horizon, a perception still shared by many today. Even from high altitudes, the curvature remains difficult to detect, raising valid questions about why it isn't more apparent. Satellite imagery is often cited as conclusive evidence, but this data is controlled by a few large organizations, such as NASA. The limited access to independent space travel leaves room for skepticism about how freely available and reliable this data really is. Additionally, private space missions, while promising, remain inaccessible to most, preventing individuals from directly verifying the Earth's shape. Rather than dismissing these concerns, we should encourage skepticism, as scientific progress depends on questioning established beliefs. Asking for more transparency and independent verification is a reasonable stance when it comes to such a fundamental issue.
While skepticism is valuable, the evidence for a round Earth is clear from both history and modern technology. The Greeks, over 2,000 years ago, demonstrated the Earth's curvature using shadows. The horizon looks for the naked eye due to Earth's size, but over long distances, ships disappearing hull first confirm curvature. Satellite images from both public agencies and private companies like SpaceX consistently show a round Earth. These images come from multiple independent sources, not just a few organizations. The overwhelming photographic and satellite evidence leaves no reasonable doubt Earth is round.
Round Earth argument relies heavily on ancient experiments like those of the Greeks, but we should ask whether their methods truly hold up today. The claim about shadows forming differently in different locations can be explained by a flat Earth model too, where the sun moves in a localized orbit above the plane of the Earth. This could account for varying shadow lengths just as well as a spherical Earth explanation. The argument that ships disappear hull first due to Earth's curvature has also been countered by optical effects. The phenomenon of refraction can cause light to bend, making it appear as though parts of distant objects disappear. This is not proof of a round Earth, but rather a result of atmospheric conditions. As for satellite imagery, it's important to reiterate the point about data control. Even private companies like SpaceX rely on similar technology and partnerships with large space organizations. This creates a lack of truly independent sources, leading to reasonable skepticism about the authenticity of the images. Why should we place unquestioning faith in images provided by organizations we cannot directly monitor? If the round Earth model is so well supported, why is it that the curvature remains virtually undetectable to the naked eye, or even with high altitude flights, leaving so many to question its existence?
Challenging ancient experiments is important, but their methods have been validated through centuries of observation and scientific inquiry. The argument that varying shadow lengths could arise from a localized sun ignores the vast scale required for consistent results across different locations, which only a spherical Earth can provide. While refraction does affect visibility, it doesn't universally account for the hull-first disappearance of ships, which occurs at predictable distances. As for satellite imagery, numerous independent agencies worldwide produce data, ensuring cross-verification and reducing the risk of bias. The subtlety of Earth's curvature is indeed challenging to detect visually, but high-altitude flights and comprehensive global measurements confirm its presence unequivocally.
While it's essential to acknowledge the contributions of ancient civilizations, we must critically assess the validity of their findings in light of modern understanding. The Greeks demonstrated a spherical Earth using methods like shadow measurements, but these were based on limited technology and understanding. For instance, the idea that the Earth's size accounts for the flat horizon does not consider how we perceive vast distances. On a truly spherical Earth, curvature should be observable across more varied altitudes and landscapes than it currently is. Regarding satellite imagery, while numerous agencies contribute data, we must consider the degree of overlap in their technology and methods. Many private space ventures collaborate with organizations that follow similar protocols, which raises valid concerns about potential bias and data integrity. The dependence on a few organizations for proof of a round Earth undermines the claim of independent verification. True independence would allow for more reliable observation, something that the public is currently limited in achieving. The absence of noticeable curvature, even at altitude, suggests that our current understanding may be flawed or incomplete.
While the contributions of ancient civilizations are valuable, their findings have been corroborated and expanded upon by centuries of scientific advancements. The observation of shadow lengths was revolutionary, and it directly supported the spherical Earth model, something that a flat Earth model cannot adequately explain across diverse locations. Regarding ships disappearing hull first, while atmospheric effects can influence perception, they do not fully account for the consistent distance at which this phenomenon occurs. This disappearing act aligns with a curved surface, not optical illusions. Furthermore, while many satellite data sources collaborate, independent satellites like those from countries such as India or Israel validate the round Earth model through diverse and consistent observations. The lack of visible curvature at high altitudes is due to Earth's vastness, where the curvature becomes subtle rather than absent, affirming that it is indeed a round planet.
While it's commendable to rely on centuries of scientific inquiry, we must remain vigilant about the limitations of historical experiments and the assumptions they carry. The methods of the ancient Greeks, while foundational, were based on observations from their time, and advancements in technology should prompt us to reassess their conclusions critically. The argument that shadow measurements support a spherical Earth overlooks the fact that those same observations could be interpreted differently within a flat Earth framework, particularly when considering localized sunlight as a variable. Moreover, the phenomenon of ships disappearing hull first can indeed be influenced by atmospheric conditions, but the distances at which this occurs can also be a result of perspective and viewing angles rather than definitive proof of curvature. If we observe closely, we might see that the hull first disappearance is not a consistent rule, but rather an effect of the viewer's position. Regarding satellite imagery, while it's true that many countries produce data, the overlap in technology raises questions about independence. Even independent sources can be influenced by partnerships or similar protocols, which diminishes their reliability. Lastly, the claim that the curvature becomes subtle at high altitudes is still puzzling. If the Earth is indeed round, why do so many high-altitude flights report seeing a flat horizon? This leads to a crucial question. If these reports of a flat horizon persist across various altitudes, what are the implications for our understanding of the Earth's shape? Are we ignoring evidence in favor of a widely accepted narrative?
Your skepticism about a spherical Earth overlooks strong supporting evidence. Ancient Greeks used shadow measurements to demonstrate Earth's curvature. These findings have been validated by modern science, which a flat Earth model cannot adequately explain. The phenomenon of ships disappearing hull first aligns with curvature, not optical illusions. While refraction can affect visibility, it doesn't account for the specific distances at which ships disappear. Independent agencies like ISRO and the European Space Agency provide consistent evidence of a round Earth, supplemented by many amateur satellite images. A flat horizon at altitude reflects the Earth's vast size, making curvature less visible. Pilots and astronauts report seeing curvature, supported by scientific measurements. While skepticism is important, it must be based on rigorous evaluation. The scientific consensus on a spherical Earth comes from extensive research and observation.
Regarding the hull disappearing first, while you argue that this phenomenon is consistent with a curved surface, it is critical to examine more closely the role of atmospheric refraction. Atmospheric conditions can create the illusion that the lower part of an object is blurrier than the upper part. The predictability of this effect does not inherently validate the spherical model. It simply shows how environmental factors can distort our perception of distant objects. Independent satellite agencies, such as the Indian Space Research Organization and the European Space Agency, it is critical to examine the degree of cooperation between these organizations. If many agencies share technology and methods, then the so-called independence of their data is questionable. The overlap of these technical systems could result in systematic biases rather than different observations. And that the curvature is less noticeable at high altitudes because the Earth is so huge does not explain why so many pilot and passenger reports describe a flat horizon. This consistent observation across flights and altitudes contradicts the concept of a uniformly curved surface. If the Earth is indeed round, why do so many first-hand accounts claim otherwise?
Eratosthenes' shadow measurements accurately calculated the Earth's curvature, which the flat Earth model cannot explain. A localized sun creates inconsistent shadow patterns that differ from the predictable angles seen around the world. About satellite imagery, multiple independent organizations around the world, including NASA, the Indian Space Research Organization, and the European Space Agency, continually produce photographs and data showing that the Earth is spherical. These are not just illustrations, but high-resolution images taken from satellites orbiting the Earth. While you question the independence of these agencies, this evidence is further corroborated by a large amount of publicly available data from amateur satellite launches, such as those launched by private companies and university projects. Many independent third-party organizations have taken images of the Earth, all of which show a consistent curved horizon. Claims that global organizations and countless amateur launches coordinate deception lack any actual or evidential basis. Let's talk about atmospheric refraction. While refraction distorts our observation of objects, its effects are well known and measurable. Refraction bends light, but it cannot consistently create the same illusion of curvature at different locations, altitudes, and environmental conditions. The disappearance of the hull is first and foremost a direct result of the Earth's curvature, which can be accurately calculated based on distance and altitude. Refraction, on the other hand, produces temporary distortions, but this phenomenon cannot be consistently explained around the world. Regarding high-altitude observations, many pilots, astronauts, and even high-altitude balloon programs have taken images in which the curvature of the Earth can be seen. Flat horizons observed at lower altitudes are not proof that the curvature does not exist. They reflect the huge size of the Earth. The curvature becomes more obvious at higher altitudes, as evidenced by photographs taken from space and high-altitude aircraft, such as the U-2 reconnaissance aircraft. In contrast, there is no reliable evidence that the Earth is flat when photographed from similar altitudes.